In 1958, a single landslide in a remote Alaskan bay unleashed a wave 524 meters high. That's taller than the Empire State Building. For just a moment, a wall of water stood taller than one of the world's most iconic skyscrapers, before crashing down with unbelievable force. This wasn't some scene from a disaster movie. It was real. The proof that waves can swallow skyscrapers is written in stone, on mountainsides all across the globe. We've found their scars, ancient and new. These waves aren't a question of if, but when and where they'll strike again. So, how is something like this even possible? And what would happen if one of these monsters wasn't aimed at a remote bay, but at our modern world? Now, when you hear tsunami, you probably think of the horrifying waves from massive undersea earthquakes, like the ones in the Indian Ocean in 2004 or Japan in 2011. Those are called tectonic tsunamis. They happen when the seafloor itself violently shoves a huge volume of water across an entire ocean. Out in the deep, these waves might only be a few feet high, but they travel at the speed of a jetliner, carrying an incredible amount of energy for thousands of miles. But the 500-meter wave? That's a completely different beast. That is a mega-tsunami. Think of it like this. A tectonic tsunami is like lifting the entire floor of a gigantic swimming pool by a few inches. The water surges out, flooding huge, low-lying areas. A mega-tsunami, on the other hand, is born from impact. It's like dropping a mountain into a bathtub. The process is called mass displacement. When a massive amount of rock, ice, or dirt suddenly plunges into the water, it creates a localized but absolutely enormous splash wave. Unlike tectonic tsunamis, these waves start out terrifyingly tall, but they also tend to lose their energy much faster as they travel. They are local terrors, capable of creating waves so high they almost defy belief. Before 1958, the idea of a mega-tsunami was mostly just a theory. Scientists had seen some weird geological clues like coastlines where all the big trees were mysteriously stripped away, but they didn't have a smoking gun. Then came a quiet July night in a place called Lituya Bay. On the night of the 9th of July, 1958, a powerful 7.8 magnitude earthquake ripped along the Fairweather Fault in southeast Alaska. The shaking was bad, but what it triggered was the main event. High above a T-shaped fjord called Lituya Bay, an entire mountainside just let go. About 90 million tons of rock and ice, a chunk of mountain heavier than 1,500 aircraft carriers plummeted 3,000 feet straight into the water. The impact was heard 50 miles away. The splash it created was almost instant and truly biblical. Water was forced up the opposite side of the inlet, scraping away every tree, plant, and bit of soil to a staggering height of 524 meters. That's 1,720 feet. When that water came crashing back down, it formed a monster wave, hundreds of feet tall, that blasted down the 7-mile bay at over 100 miles per hour. Amazingly, people saw it happen. 3 fishing boats were anchored in the bay that night. On one boat, the Edry, Howard Ulrich, and his 7-year-old son were shaken awake. Looking up the bay, Howard saw something that didn't make sense. The mountain itself seemed to be twisting, before an immense wall of water exploded upwards and started racing toward them. He somehow pulled his anchor just in time for the wave to lift their boat, carrying it up and over the spit of land at the bay's entrance and out into the Gulf of Alaska. They survived. Another boat was also swept out to sea, its crew miraculously surviving too. The third boat wasn't so lucky. It was hit directly, and its 2 occupants were killed. Afterward, the evidence was undeniable. A sharp trim line, like a giant haircut, was carved into the mountainsides. Below 1,720 feet, The thick forest was gone, replaced by splintered naked rock. Above it, the forest was untouched. Lituya Bay was the proof of concept. The moment theory became terrifyingly real. So, Lituya Bay proved it could happen, but was it just a freak event? A 1 in a billion anomaly? Geologists have since found the answer is a hard no. The planet keeps a diary of its most violent moments, written in layers of sediment and giant, misplaced rocks. All over the world, scientists have found evidence of prehistoric mega-tsunamis that would dwarf even the biggest earthquake-driven waves. In the Canary Islands, for instance, massive volcanic collapses over hundreds of thousands of years have created waves of incredible size. On the island of Tenerife, deposits show waves may have reached up to 270 meters high. How do they know these were waves? The evidence is in things that just shouldn't be where they are. Imagine finding massive boulders from the ocean floor, weighing tons, sitting on hillsides hundreds of feet above sea level, miles inland. Gravity can't do that. Only one thing can: a wave of almost unimaginable power, scooping up chunks of the seafloor and tossing them onto the land like they were pebbles. There's even startling evidence on other planets. Scientists studying Mars have found features that suggest when it had a northern ocean, it was hit by 2 different mega-tsunamis caused by asteroid impacts. These waves, estimated to be up to 120 meters high, literally reshaped the ancient Martian coastline. If it can happen there, it can definitely happen here. Lituya Bay wasn't an anomaly. It was just the first one we were around to see. We know it's happened before. But where could the next one come from? Scientists are monitoring several ticking time bombs around the globe. Maybe the most famous is the Cumbre Vieja volcano on La Palma in the Canary Islands. For years, there's been concern over the stability of the volcano's western side. A massive block of land has shown signs of slowly creeping toward the Atlantic. The original theory that got everyone's attention was that a big eruption could cause the entire flank to catastrophically collapse into the ocean all at once. The models for that worst-case scenario were apocalyptic, suggesting a wave hundreds of meters high that would race across the Atlantic, hitting the coasts of Africa, Europe, and North America. But the science on this has been updated. More recent studies suggest a collapse is way more likely to happen in smaller chunks over time, creating a series of much less destructive tsunamis. So while the risk of a Hollywood-style megawave from La Palma is now considered very low, the volcano is still a powerful reminder of the forces at play. You might think these events are confined to history books or far-off future scenarios, but they're not. A major mega-tsunami happened just a few years ago. On the 17th of October 2015, in another remote part of Alaska, it happened again. In Tanfjord, not far from Icy Bay, a mountainside destabilized by a retreating glacier let go. Around 180 million tons of rock slid into the fjord, creating a mega-tsunami that ran up the opposite slope to a height of 193 meters, that's 633 feet. For perspective, that's one of the largest tsunami waves recorded in the last century. Because the area was totally uninhabited, no one was killed. In fact, nobody even knew it had happened until scientists noticed the massive landslide on seismic sensors and checked the satellite photos. The images showed a huge swath of forest and soil on the shoreline simply gone, scrubbed clean down to the bedrock. This event wasn't triggered by an earthquake. It was a direct result of the Tyndall Glacier retreating, removing the support that held the mountainside in place. The 2015 Tan Fjord wave is a stark and terrifying confirmation. These events aren't just history. They are a part of our present, and as the climate changes, they may become more common. This brings us to a strange but important paradox. The tallest waves in history have been some of the least deadly. The 524-meter wave at Lituya Bay killed 5 people. The 193-meter wave at Tan Fjord killed 0. Now, compare that to the 2004 Indian Ocean tsunami. Its waves reached a maximum of around 50 meters, less than a third the size of Tan Fjord's, but it killed over 230,000 people in 14 countries. The 2011 Japan tsunami, with waves up to 40 meters, left nearly 20,000 people dead. Why the huge difference? It all comes down to location and mechanics. Landslide-generated mega-tsunamis are incredibly powerful where they start, but they are local. They happen in specific, contained places like fjords, and their energy fades relatively quickly. So far, we've been lucky that the biggest ones have hit remote, empty areas. Tectonic tsunamis are the opposite. They are planet-wide events. The energy from a shifting seafloor can cross an entire ocean, delivering destruction to coastlines thousands of miles away. A 30-meter wave hitting a packed city is infinitely more catastrophic than a 500-meter wave hitting an empty mountainside. It's a sobering thought that when it comes to disasters, sheer size isn't the only thing that matters. Proximity to people is what turns a geologic event into a human catastrophe. So, let's go back to the original question. Is a 500-meter tsunami possible? The answer isn't just yes. It's that it has already happened. The 524-meter wave at Lituya Bay in 1958 is the terrifying proof. And the shocking 193-meter wave in Tan Fjord in 2015 showed us that the forces that create these monsters are very much active today. The science is clear. Wherever you have steep mountains, unstable rock, and a lot of water, you have the recipe for a mega-tsunami. As glaciers continue to melt and retreat in our warming world, the slopes they once supported are becoming weaker, potentially making these landslides happen more often. We live on a planet of incomprehensible power. The forces that shape our world operate on scales far bigger than our own lives, and the evidence is written in the rock all around us that events of incredible violence are just a natural part of Earth's cycle. We can't stop them. We can only understand them, respect the power they represent, and be as prepared as we can. The 500-meter wave is not a myth. It is a documented, understood, and terrifyingly real phenomenon. And maybe the most chilling thought of all is that the question was never really if the next one will happen, but when and where. If you want to explore more of the incredible forces that shape our world, check out our video on supervolcanoes next. And to make sure you don't miss our next deep dive, be sure to subscribe and hit that notification bell. Thanks for watching.